Good morning, student. I am Professor Dr. D.N. Zambre, Head Department of Chemistry, Kisan Veer Mahavidyalaya. Why? On the basis of difference, hard and soft acid and bases, we are going to explain some applications which are implemented in the hard and soft acid and bases chapter. First application is to determine the relative strength of hydra acids. Like hydra acid, it is nothing but the acids which contain hydrogen. For example, HF, HCl, HBr, and HI. In aqueous solution, relative strength of HF, HCl, HBr, and HI can be predicted the reaction of the acid with the water. For example, if you take any acid from this particular acid and if you dissolve in water, what happen? One proton, this proton can be donated to this one and formation of H3O plus formation takes place plus X minus. X minus, it is nothing but Cl, Br and I. Here it is represented X is equal to F, Cl, Br and I. The hardest base F will be most successfully and strongly bounded with the hard acid like H plus. Hence, it will be highly stable because it obeys the Pearson rule. It means hydrogen is a hard acid and fluorine is a hard base. That's why if the even combination is there, then it obeys the Pearson rule. Otherwise, it is unstable. Next one, if you consider, suppose if you consider HX plus, suppose if you take I minus, here HI formation takes place. But hydrogen is a soft acid and iodine is a hydrogen is a hard acid and iodine is a soft base. That's why the combination is an odd combination. It cannot obey the Pearson rule. Therefore, HI is very less stable as compared to HF. It means here, if you observe, the stability goes down, decreases. Stability goes down, decreases from HF to HCl to HBr to HI. It means this is the sequence. This is the first application. Second application, to determine the relative stabilities of the complexes in aqueous solution. Depends upon the Pearson rule, we can explain the some complexes. For example, beside that, another complex we are going to select COF 6 square bracket complete and the charge becomes -3. And suppose if you take COI6 square bracket complete and -3 charge. Here cobalt is the hard acid. This is the hard acid. This is the hard base. This is the hard acid because this is the transition metal and this is the soft base. Here hard and soft. Here hard combination is there. Therefore, it obeys the Pearson rule. And COI6 here combination is a hard base, hard acid, and here soft base. The combination is odd. It cannot obey the Pearson rule. That's why it becomes stable. Suppose if you take another complex like CONH3 6 and if you take COCN6 complex. Here actually cobalt is a hard acid and NH3 is a hard base. Here if you observe, this cobalt is a hard acid and here cyanide is the soft base. The combination is odd. Here it obeys the Pearson rule because hard acid always combine to hard base and hard acid is do not allow to combine soft base. That's why this complex becomes very stable because it obeys the Pearson rule. Then predict the course of reaction. What is meant by predict the course of reaction? The predict the course of reaction, it is nothing but any reaction if you want to carry out, whether this is the forward direction or backward direction. For example, if you take hydrogen combined, this is the hard acid, this is the hard acid, and if you take this is the soft acid, and if you take this is the hard base, OH is a hard base. Here soft and hard combination is odd. Therefore, here if you observe, yeah, H2 it is nothing but H and OH. Hydrogen is a hard acid. Hydrogen is a hard acid and OH is the hard base. Here this is the soft acid. This is the soft acid. That's why HO is, it becomes stable because hard acid combined with hard base. That's why this reaction is favorable to forward direction. Reaction number 1 is favorable to forward direction. In case of second reaction, hydrogen is hard acid. CH3Hg is the soft acid and this is the hard base. Hydrogen is the hard base. Here H2S, this is the hard acid and sulfur is the soft base. Here this is the soft acid. Here hard soft combination is there. Here if you observe the combination, here hard base, soft base, here hard acid. It means here this reaction is favorable to, here this is the soft base, hard soft acid and here soft base. The combination is favorable. That's why reaction number 2 favorable to backward direction. Next, classification of cation on the basis of that Pearson rule. Graphically, if you observe, this patch becomes the hard acid, this patch becomes the soft acid, and middle patch becomes the borderline. If these hard and soft acid and bases are classified in different two categories on the basis of the graph, it means here this combination is favorable. Hard acid always prefer to combine hard base and soft acid always prefer to combine soft base. It means here hard soft combination when favorable, then and then complex formation takes place. It means on the basis of that we are going to explain whether that reaction is favorable to forward direction as well as backward direction. Then next application is the classification of neutral molecule, classification of neutral compound. Neutral compound like H2O, CO, then NH3, these are the soft combination, so hard combination, and the ligand which is get classified in on the basis of neutral molecule, then negative molecule and positive, and then we are going to decide the particular complex is whether stable or unstable, and last one is the to determine the hard and soft combination. By applying the Pearson rule, we are going to decide which is the hard acid, which is the soft acid. For example, if you take lithium, lithium is belonging to the hard acid because this is the alkali metal. Iodine is the belonging to the soft base. Here cesium is the hard acid because this is the bigger in size, and this is the chlorine is the this is the soft acid and this is the hard base. Here combination is not favorable. Hard soft hard. Here lithium is the hard acid, chlorine is the hard base and cesium is the soft acid, iodine is the soft base. Here hard combination is there, here soft combination is there. Therefore, this combination is a very stable compound according to the Pearson rule. If you take here lithium is hard acid, and iodine is the soft base. Here cesium is a hard acid, then this is the soft base. Lithium is a hard acid, then chlorine is the hard base. Cesium is the soft acid, this is iodine is the soft base. If you take any type of the complex, we can determine whether there is a hard combination or soft combination, and on the basis of that we are going to come to the conclusion whether this is the stable complex or not stable complex. Then symbiosis. Next application, symbiosis. What is meant by symbiosis? Symbiosis, it is nothing but BF3 is a hard acid. A hard acid and combination readily with the further F minus ion, which is a hard base, while BH3 being a soft acid preferred to join the soft base. It means each and every application there is the applicable which type of combination is there, whether there is a hard or soft. Thank you.